yeah, the FT, right? So sorry about that. We don't have yet finished because this is FT. So we need to answer this question, right? So this question, FT is Laplace only inverse this one. So when we have exponent in the question, so in that video, last video, we have ft minus 4, ut minus 4, right? Okay, so if you can see the previous video, so ft minus 4, so now we have ft is 1 minus e negative 4t. So now we ft minus 4, so we just substitute our t now becomes t minus 4. So this is called type of function, so we substitute t as t minus 4 over here. Can you see? 4t, t is substituted by t minus 4. So into the function. So this is conclude our question A. Example A, think in the notes. So this is the final answer. So if you have exponent, you should have u as your final answer. Okay? Okay, now we go on to the next example. The next one. So if you don't understand, you just focus at this example. The next example is, I'm going to show you B. Okay, B. Laplace inverse. So we have exponent s plus 3 divided by s squared plus 1. Okay. So again we have exponent over here. So this is our fs. So what is our property? When we have e negative as fs, so we have ft minus a u t minus b. Okay, so this is our property for second shifting, right? So this is question including exponent. So the next of the exponent is fs. So this is fs of function. So now we have this, and then it becomes ft. Identify your a. A is power of exponent over here, pi. So tft minus pi, t minus pi, ut minus pi. This is general answer for this. So we need to find ft minus pi. So in order to find ft minus pi, we need to find ft. So what is ft? Ft is the inverse of fs, right? Okay. So what is fs? Fs is, this is fs, s plus 3 over s squared plus 1. Again, for the second example, we have fractions. So we don't have formula for this in the tables. So we need to modify. So this is a need to be in partial fractions. Okay. So we have to change into partial fraction. This is linear, a over s. This is quadratic factors, right? Remember our quadratic factors, what will be the numerator? So will be bs plus c over s squared plus 1. Okay, let you see? Because of the quadratic factor. Okay, so we just equalize the numerator. Okay, so a, we have s over here, we cover s, so s squared plus 1. So bs plus c, we cover s squared plus 1, cover this one, so s multiplied by s. Okay, So now we do the elimination first, because this is a technique, combined technique. When we deal with the quadratic, we have to use both techniques, elimination techniques, in order to find the constant, and also we need to compare coefficient as well. Okay, so just eliminate. We have A, B, C, three constant, A, B, C. So we need to eliminate two of them out of three. So the easiest is to eliminate B and C first. So in order to eliminate B and C, S will be 0. So 0 times any function will be 0. So B and C eliminated. So S equals to 0. Substitute into all the functions. So it becomes 3. S 0. So A equals to 3. So straight away get the answer, right? Okay. Now we need to find B and C. So one of the technique is compare coefficient. So B is at S square, right? The coefficient of S square, yeah. So we compare S square, coefficient of S square. So now compare coefficient of S square. For the left hand side, no S square involved. So for 0. For the right hand side, we have A. For this, you should multiply when you want to compare coefficients. Multiply the brackets out. Multiply out the function. So where else? So S square over here. So S square, the coefficient is B. So A plus B. A plus B. So we have just now A equals to 3. So B equals to negative 3. Because A is 3. Okay, now we substitute back into our fraction, partial fraction. A equals to 3 over S plus B. B is negative 3 S. Okay, so C equals to, we don't have, we need to find C, forgot. Okay, C is coefficient of S. So the S for the hand side is 1. So for this side, C. Okay, it's easy. Just straight away got the C. So now that we can put into our function. So B is to negative 3, C is to 1. So just write C first, because C is positive, to avoid any mistake later. So S square plus 1C. I just make the B, just should the C put in front, because C is positive. So it's clear. Okay, so 3 over S is 3, Laplace integral over S. And then now we have this. How do we transform this, inverse transform this? So this is not straightforward. So we just write first the inverse for this. We need to modify this, right? So you see, we don't have function like this in the table. We do have this in the table, but we don't have this at the top. In the table, we need to separate. Okay? So what happened is, we need to separate this. Laplace inverse 1 over S square plus 1 minus 3S over S square plus 1. Okay? Did you see this? Sorry about this. Okay, so now our function just now, 3 over S plus 1, 3 minus S squared plus 1 is 3 plus, so inverse 1 over S squared plus 1 is sine T for this, and for this is minus 3 cos, right? Cos A is 1, so cos t. Okay, oh, this is ft. It's this side ft. So we need to substitute back into our question. Our question is this. So ft minus pi, right? We want ft minus pi. We have ft is this, so substitute all the t's, t here in terms of t with t minus pi, because we want ft minus pi. This is ft. So 3, sorry, here